Hi guys, this is the next part of the How to Learn C++ tutorial, and in this one we are going to focus on control flow and start with some simple OOP concepts. So this is where we stopped. We defined some functions in a custom namespace and we added a point data type that we will extend later on. Now let's come back to the main program, to the main function. And I will show you how to control the flow of your program by using the if statement. So this is actually quite simple. With the if statement, you check if a condition is true, like here if the distance is greater than a certain value. And then you open a new block with these braces, and if the expression is true, then this block is executed. Then we could write out something to the standard out, just to indicate that we are in this block and that the expression distance is greater 15 is true. Then we can compile and start the program. And here you can see the distance is 12, so the condition is not true. And this is where the else if comes into play. And here we could, for example, check if the distance is greater than, let's say, 10. Or I could also check if it is greater or equal to 10. Then I open again a new block and write out something like this. Okay, and we know that this is true. And here we get the result when we start it. What I can also do in another else if statement is to check if the distance is exactly a certain value, like 12. Then I have to use the double equal sign in the condition. So this was the else if to check if another condition is true, but we could also open a block that is executed if none of the conditions before are set to true, and for this we can use the else statement. Okay, now let's start this. And you see for the result of 7 we have no matching. Okay, now let's come to a different method to control the flow of your program, and this is using the switch statement. When using the switch statement, you also check a condition and you perform different actions based on the conditions, and these actions are defined with the keyword case. But we have one problem here. We can't use double values. The switch statement needs an integer as expression. So let me write this here to the end. Although it's erroneous, I check here if the distance is exactly 7, then I write this to the output. And I use the break keyword to end the switch statement. But now let's define an integer variable that we use in this switch statement. So I define this here and call it iDistance and assign a value. Okay, you already see IntelliSense tells us that everything is okay, and we could compile and start the program now. After that I define a default case, and this is executed if none of the previous cases are matching. Before we go on, let me comment out this if statements because we don't need it currently. And then let's move on to turn this distance double value we have into an integer. And this is quite simple. You can just assign this distance to the iDistance. And what happens is that C++ rounds down this value, this double value, into an integer. But of course we won't see this if we don't have any decimal places. So let's change the value of the point. Now we have 15.8 something. And we can write this out and you will see that this is 15. The compiler gives us a warning because a conversion like this could mean a potential loss of data. Okay, but now we can use this in the switch statement and check, for example, for the condition 15. By the way, the STL offers a round function that computes the nearest integer value, rounding halfway cases away from 0. When we are using this function, the result is 16. Alright, the last thing that I want to show you for the switch statement is the fall through to combine cases. For example, I want to check if the condition is 15 or 16, then this can be done. like that. Okay, this was a simple start, I guess. Now let's get rid of these lines and have a look at the point structure we created last time. The point has an x and y variable, and I want to be able to get a representation of this point to print out the values of these variables. The representation should be a string. This means we have to convert the double variables to string, and therefore we need to include the STL string header to the std AFX header. And now we write a function directly into the struct data type to return a string representation of the point. This is a first step to object-oriented programming. We are defining a function for an object. These functions are called then methods. Our method is called toString and returns an STL string. For the result of the method, I define a result string variable, and because I included the string header, I can use the function to_string defined in the std namespace. I use this to convert the x and y variables to string. Then I concatenate the strings and store it in the result variable, which I return as result. The concatenation to the result variable can be done by using the += operator. Okay, we defined the toString method for the point, so now let's use it here in the main function. And here's the result. When I compile and start, the representation of our first point as string. I think I will adjust this a little bit just to improve the readability. Yes, this looks better. Okay, so far so good. What I want to do now is to add point objects into a list, loop over this list, and print out the representations of these objects. So let's get rid of the stuff we don't need anymore and clean up the code. I will also use the namespace math functions. And then I will show you how to include and how to use a list to store our point objects. So I switch to the std AFX header and include the header vector of the STL. The STL vector is a dynamic array to store elements of a given type in a linear arrangement, and this means you don't have to define how many objects it will contain, but just of which data type these objects will be. So let's do this for the point structure. Declare a vector. Now you define the data type. The data type is point. This has to be defined in angle brackets. Then give this new vector a name, and I will call this points, and that's it. We defined a list of points. Now we'll create a third point. We have 2. Let's just copy this and name this P3 and use different values for it. Okay, and now we can use a method of the vector. This is called pushback to add these points to the list, to the vector. Here it is, pushback. And we do this for every point. There are different and more convenient methods to initialize a vector, but we will stick to this pushback now and come back to this later on when we talk about initializer lists, for example. Okay, now we have a dynamic list that contains 3 points, and I want to show you how to iterate over this list using a for loop, and then we make use of our new toString method of the point to print out the representation of all these points. So what's the syntax of a for loop in C++? Well, there are many syntaxes, many possible ways to iterate over a collection of items, of elements, but I want to use the range-based for loop. You just have to write for, then the current element, and after the colon, the collection of elements that you want to iterate. This syntax is available since version C++ 11, and it is implemented for all collections of the STL. Okay, here we are iterating, and inside of this block, this means in every iteration step we want to print out the representation of the current point. And that's it. Now we can start the program. And here is the point list. Okay guys, I will stop here and I hope you learned something and find this useful. In the next video we will focus on object-oriented programming with C++. If you like my channel, please subscribe, and if you want to support it, please consider being my patron so that I can keep the quality and quantity of my videos. Thanks for watching this, and I hope you come back soon.